Power and its importance. Infrastructure. Infrastructure is the basic physical and organizational structures needed for the operation of a society or an enterprise. The term infrastructure typically refers to the technical structures that support a society, such as roads, water supply, sewers, power grids, telecommunications, and so forth. The term infrastructure may also include basic social services such as schools and hospitals. Infrastructure facilitates the production of goods and services. Infrastructure can be divided into two categories: economic and social. Economic infrastructure is essential for improving the productive capacity of the nation. It includes energy, power, telecom, transport, railways, roadways, aviation and shipping, infotech, finance, etc. Social infrastructure helps in the development of human resource in an economy. Infrastructure associated with education, medical facilities, sanitation, housing, drinking water supply, etc. fall under this category. Let us learn about power sector as an important infrastructure component in detail. Power sector. India is the world's 6th largest energy consumer. The demand for energy has grown at an average of 3.6% per annum over the past 30 years. The total demand for electricity in India is expected to cross 950,000 megawatts by 2030. Some of the sources of power generation are: 1. Through thermal power plants. A thermal power plant is a power plant in which the prime mover is steam-driven. Water is heated, turns into steam and spins a steam turbine which drives an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. 2. Through hydroelectric power plants. Hydroelectricity is the electricity generated by hydropower. It means the production of electrical power through the use of the gravitational force of falling or flowing water. It is the most widely used form of renewable energy. 3. Through nuclear power plants. Nuclear power is the 4th largest source of electricity in India after thermal, hydro and renewable sources of electricity. As of 2010, India has 20 nuclear power plants in operation, while 4 others are under construction. 4. Through wind power. Wind power is the conversion of wind energy into a useful form of energy, such as using wind turbines to make electricity, windmills for mechanical power, wind pumps for pumping water or drainage, or sails to propel ships. 5. Through solar power. Solar power is the conversion of sunlight into electricity. Sunlight can be converted directly into electricity using photovoltaic or PV, or indirectly with concentrated solar power or CSP, which normally focuses the sun's energy to boil water, which is then used to provide power and other technologies. PV converts light into electric current using the photoelectric effect. As of September 2010, we generate 18 megawatts from solar sources, but it is expected that 150 to 200 megawatts of solar power will be installed in the country by December 2011. Statistics for contribution to electricity production are as shown. The country has also invested heavily in recent years in renewable sources of energy such as wind energy. As of 2008, India's installed wind power generation capacity stood at 9,655 megawatts. India has committed massive amount of funds for the construction of various nuclear reactors. In July 2009, India unveiled a $19 billion plan to produce solar power. Let us now discuss how the generated electricity at various stations reaches the ultimate consumer. Challenges in the power sector. Transmission of electricity is defined as bulk transfer of power over a long distance at high voltage, generally of 130 kilovolts and above. In India, bulk transmission has increased by approximately 45 times as compared from 1950 till today, as stated by Power Grid Corporation of India. The entire country has been divided into 5 regions for transmission systems, namely Northern Region, Northeastern Region, Eastern Region, Southern Region, and Western Region. The interconnected transmission system within each region is also called the regional grid. Ability of the power system to safely withstand a contingency without generation rescheduling or load shedding was the main criteria for planning the transmission system. However, due to various reasons, certain pockets in the power system could not safely operate even under normal conditions. Distribution of energy is the provision of energy till the ultimate consumer. The total installed generating capacity in the country is over 164,700 megawatts and the total number of consumers is over 144 million. Apart from an extensive transmission system network which has developed to transmit the power from generating station to the grid substations, a vast network of sub-transmission in distribution system has also come up for utilization of the power by the ultimate consumers. However, due to lack of adequate investment on transmission and distribution works or T&D, the T&D losses have been consistently on the higher side and reached the level of 32.86% in the year 2000 to 2001. As the transmission and distribution loss was not able to capture all the losses in the network, concept of aggregate technical and commercial or AT&C loss was introduced. AT&C loss captures technical as well as commercial losses in the network and is a true indicator of total losses in the system. High technical losses in the system are primarily due to inadequate investments over the years for system improvement works, which has resulted in unplanned extensions of the distribution lines, overloading of the system elements like transformers and conductors, and lack of adequate reactive power support. The commercial losses are mainly due to low metering efficiency, theft and pilferages. This may be eliminated by improving metering efficiency, proper energy accounting and auditing, and improved billing and collection efficiency. Fixing of accountability of the personnel of feeder managers may help considerably in reduction of AT&C loss. Electricity losses in India during transmission and distribution are extremely high and vary between 30 to 45%. In 2004 to 2005, electricity demand outstripped supply by 7 to 11%. Due to shortage of electricity, power cuts are common throughout India, and this has adversely affected the country's economic growth. Despite an ambitious rural electrification program, some 400 million Indians lose electricity access during blackouts. While 80% of Indian villages have at least an electricity line, just one half of rural households have access to electricity. In urban areas, the access to electricity is much better compared to rural India. The overall electrification rate in India is 64.5%, while 35.5% of the population still live without access to electricity. Power sector faces many challenges due to the transmission and distribution losses, theft of electricity, etc. The result is that many rural parts in India are still in darkness. Over 40% of the country's population currently do not have energy access. Measures should be taken to improve the conditions of such areas. Power has now become a necessity, so it should be provided to everyone. The Indian government should take preventive measures so as to decrease the loss of electricity. To summarize, power is an essential requirement for all facets of our life. It has been recognized as a basic human need. It is the critical infrastructure on which the socio-economic development of the country depends. The growth of the economy and its global competitiveness hinges on the availability of reliable and quality power at competitive rates. The demand of power in India is enormous and is growing steadily. The vast Indian power market today offers one of the highest growth opportunities for private developers. Along with this quantitative growth, the Indian electricity sector has also achieved qualitative growth. This is reflected in the advanced technological capabilities and large number of highly skilled personnel available in the country. While this must be appreciated, it must also be realized that the growth of the sector has not been balanced. The availability of power has increased, but demand has consistently outstripped supply. Besides, in the case of those who do have electricity, reliability and quality are matters of great concern.